Hi everyone, this is teacher Justina and welcome back to my channel. And then if you are new, then do not forget to subscribe, like, and share. And also hit the notification bell for more video updates. And also, please do watch my video from the very beginning all throughout the end because I'll be giving examples from easier to difficult. And please do not forget to leave your comments below and you can also suggest topic. Our video for today is all about parabola. This is one of the conic figures, and this is for pre-calculus for grade 11 STEM strand. Okay, so let us explore what is parabola. So the parabola is a conic figure or a curve which is a set of all points in a plane that are the same distance from a line in the plane, and that line uh, is said to be the directrix as from a fixed point in the plane, which is the so-called focus. So let us explore. So you are given this figure of a parabola, okay? And what are these different parts of a parabola? So as it is being said, it is a conic figure or a curve. So as you have seen this line, this is a curve. So what are these different parts of a parabola? So we have the vertex. The vertex is said to be the turning point of the parabola and found in between the focus and the directrix. So found in between. So this is the vertex, the focus, and the directrix. Okay? And then the next one is the focus. And this point is said to be the focal point. So this is the fixed point in the plane. And the length of this from the vertex is 1/4 of the constant in the equation. So that C refers to the constant of the linear part of the standard form of the equation of a parabola. And 1/4 absolute value of the constant from the vertex, and it is found inside the curve. So the focus is found inside the curve. Okay, the next one is the directrix. A directrix is a line, and this is a fixed line. So the fixed line in the plane, and still how many units from the vertex going to the focus is also same units from the vertex to the directrix. So if vertex is in units to the focal point, the directrix also is also in units going to the from the vertex to the directrix. And then the next one is the latus rectum. The latus rectum, this one, okay, it passes through the focal point or it passes through the focus. It is a segment that passes through the focus and whose length is c units. So the standard form of an equation of a parabola, the c refers to the numerical coefficient of the standard form. So that is the latus rectum. And then what is this axis of symmetry? The axis of symmetry is uh, a segment that divides the parabola into two equal halves. It intersects the curve at the vertex. So if it intersects the curve at the vertex, that means that the axis of symmetry divides the curve into two equal parts. Okay, so as it is mentioned, that any point on the curve, meaning any point on the curve. So as you have seen, that this is our curve and any point is equidistant to the focus as our fixed point and to the directress, to the fixed line. So as you have seen from this point, going to the fixed point which is the focus 6 units, and then this point going to the fixed line which is the directrix is still 6 units. So we need not to use the distance formula anymore because this is a vertical and horizontal distance, and by just counting it this way we can get a 6 and all throughout going to the directrix still 6 units. Now what we are trying to prove this time is uh, how true that this point A, because this is still any point on the curve, we are choosing the second point. This A Going to the focal point, is this really 13 units? And A to C, this is a vertical distance by just subtracting 16 minus 30, the y coordinates, because this is parallel to y. So we will be subtracting the 16 and the 3, the y coordinates, we can get 13. So as you have seen, it's 13. What we are trying to find out is how true that this B, which is 5, 9, to A is really 13. So recalling the distance formula, so our x sub 2 is 5 and our x sub 1 is 16. So 5 minus 16 squared plus our y sub 2 is 9. That's 1 minus our y sub 1, which is 16. So to further simplify, negative 11 squared plus negative 7 squared. And for that, we have the square of negative 11 is 1 to 1 and the square of negative 7 is 49, and AB is now a square root of 170. And the square root of 170 is approximately 13.03. So actually they are approximately correct. Maybe it's either this point A, the coordinates of this point A, it's either 16 and something, it's maybe this is 15.99. Well, anyway, 13.03 is uh, approximately same with 13. Okay, so let us now familiarize the standard form of the equation. So the standard form of the equation of the parabola with vertex HK, so as we have known that vertex is one of the parts of the parabola. So vertex HK and concave either up or down with the axis of symmetry parallel to the y-axis. So again, we have the vertex HK and we have the axis of symmetry. The axis of symmetry divides the curve into two equal halves. So when it is parallel to the y-axis, it will be described by the equation, the standard form, x minus h squared is equal to c times y minus k. As you have seen, that our x part is being squared and our y part is has an exponent of 1, and there is that c refers to the constant. Now again, if x is being squared, remember that the concavity, when we say concavity, the opening, so when we say the x is being squared, your parabola will concave either up or down. But when can we say it will be concaving up? Okay, it will concave up if C, this one, is positive, and if C is negative, it will concave downward. So let us have the image. So as you have seen, if C is greater than 0, and this refers to positive, you have seen the curve, it will be facing up. And so there is a focus, there is this vertex, and there is that directrix. And the axis of symmetry, it is being referred to parallel to the y-axis. Of course, this is parallel to the y-axis, this one. Okay? And then as it facing down, still the directrix, the fixed line, the vertex, and the focus. And then the axis of symmetry still divides the curve into two equal halves. So what will happen if it will be facing left and right? Okay, the standard form of the equation with vertex HK. Okay, where is the so-called vertex HK there? So uh, when we say H and K, we will be getting the vertex coordinates from the H and K of your equation. So if your y is being squared, unlike here the x is being squared. So this time if the y is being squared, you have to think that what is on the right, the linear part is x. So I'm sure the x is a horizontal line. So if it is x on the right part, we will be expecting to have its opening either left or right. So again, if y is being squared, the concavity is either left and right. But if x is being squared, Okay, again, if x is being squared, the concavity is up and down. But if y is being squared, the concavity is either left or right. When can we say it will be opening right? If c is positive, otherwise, if c is negative, it opens left. So as you have seen, if c is greater than 0 or positive, it concaves right. If c is less than 0 or negative, it will concave left. Okay, so let us now have this example. We have to graph a parabola being described by this equation. X minus 3 squared is equal to 12, then y minus 4. As you have seen, the x is being squared, the y is not. So what we are trying to expect. Okay, so I hope you have all the steps. Put in standard form, squared term on the left. Okay, it's done. The squared term is already on the left, so it's done. Decide which way the parabola opens. Okay, so where is the opening of our parabola? So, x is being squared, so the y is on the right. So meaning, okay, x is squared and 12 is positive, so opens upward. Okay, again, the y is on the right. That means your parabola opens upward or downward. But since our 12 is positive, then it opens up. So the vertex is 3, 4. Why 3, 4? In which we have x minus 3 and y minus 4. Okay, so getting the vertex, we will be getting the additive inverse. So when we say additive inverse, so if it is negative 3, its additive inverse is positive 3. If it is a negative 4, its additive inverse is positive 4. Or in other words, if this is positive 3, then our vertex will be negative 3 as the x coordinate. Or if this is y plus 4, and then our k or our y coordinate of our vertex will be negative 4. But since it's negative 3 and a negative 4, their additive inverses are positive 3 and 4. Okay, next. Okay, so again, it's the h and it's the k. That is why we have vertex 3, 4. Okay, plotting the vertex. That is the vertex, and its coordinate is 3, x is 3, and y is 4. So as you have seen, x is 3, this one, x is 3, and y is 4. The next, the focus will be determined by dividing the constant always by 4. Or in other words, 1/4 of the constant. So what is 1/4 of 12? So it's 3. That means we need to count 3 units from the vertex going to the focus. And remember, your parabola will be concaving up. So that means from the vertex, you need to count 1, 2, 3. So from the vertex, you have to move 1, 2, and 3. That's your focus. Okay, and its coordinate will be x is 3 and y is 7. We're done with the focal point. Let's proceed to the directrix. So how many units from the vertex going to the focal points? We have 3 units. And same with uh, sketching the directrix, will be counting 3 units from the vertex. 1, 2, and 3. There is your directrix. And since this is a line, what is its equation? So the equation is y equals positive 1. Why this is y equals positive 1? Because your line crossing the y at positive 1. So the equation of your directrix is y equals 1. Okay, the next, the latus rectum. A latus rectum is a line segment that passes through the focus. And what is the length of your segment? Because when we say latus rectum, it is a segment. And when we say segment, we have known already that a segment is a portion of a line with 2 endpoints. So therefore, the latus rectum can be determined by looking the constant. So what is the constant of our equation? It's 12. So therefore, that means we have to move 6 units right and 6 units left. So here it is. The latus rectum is 12 units. So 1, 2, 3, 4, 5, and 6. And the endpoint going to the right being described by the coordinates 9, 7. Okay, what about the other end? Because it is being mentioned that 6 units to the right will be also moving 6 units to the left. 1, 2, 3, 4, 5, 6. And there is the second endpoint. So the endpoints are negative 3, 7, and 9, 7. So we are done sketching the vertex, the focal point, the directrix. Are we now ready sketching the curve? Okay, so the latus rectum is 12 units. Are we now ready sketching the curve? Okay, sketch the curve with vertex. Okay, again, sketch the curve with vertex as turning point. So where is the vertex? This one. So we will be expecting that our curve will be turning in this point because vertex is said to be the turning point. So that's it. So this is the vertex. And remember that the endpoints of your latus rectum are very important in sketching your parabola. So are we done? Not yet, because where is that axis of symmetry that divides the curve into two equal parts? Okay, so the axis of symmetry, whatever your x in your vertex, whatever your x in your vertex will be the equation of your axis of symmetry. So your axis of symmetry, this one, is crossing the x at 3. Again, and again, whatever your x coordinate of your vertex will be the exponent, I'm sorry, will be the equation of your axis of symmetry. Axis of symmetry equation, x equals 3. The directrix equation is y equals 1. Okay, so since we are done graphing a parabola with the following steps, let us now find the equation of a parabola. Okay, so the given problem there is write the equation with the parabola with the focus at 3, 5 and the directrix at x equals 9 in standard form. Okay, so since the graph is facing left, so as I have seen in the graph, so since the graph is facing left, so the equation is described by y minus k squared is equal to c times x minus h because this is facing left. So meaning the x part is on the right. And then next, the distance from the focus to the directrix is 6 units. As you have seen, this is the focus 3, 5, and then the directrix is 9. It is crossing the x-axis at 9. That means focus of the directrix is 6 units. And remember that our vertex is in the middle of the focus in the directrix. So therefore, meaning from the focus to the vertex and vertex to the directrix is 3 units. So again, the focus is 3 units away from the vertex as well as the directrix. And for that, the vertex will be 6, 5. So meaning, this one is 3 and counting because 3 units from the focus is the vertex. So we have 6, 5. And for that, the vertex is 6, 5, meaning in our equation, the h is 6 and the k is 5. And for that, the standard form that we need to follow is this. Y minus k squared equals 6 times x minus h. And therefore, we just simply copy the y and then substitute. Where is our k? It's a positive 5. So meaning that is coming from its additive inverse, which is negative 5. And x will be copied. And then this is minus 8. And our 8, or the x coordinate of our vertex, is 6. So it is x minus 6, because the vertex 6, 5, the 6 as the x coordinate of your vertex is coming from x minus 6. But we are trying to get the value of our constant. So the constant, this one, the constant on the linear part. So what should it be? Okay, so remember that the focus is 3 units from the vertex. Okay, and why we have a negative 3? Okay, remember that the focus is um, one fourth of your constant. And then the focus is already 3 units, so that means multiplying 3. I'm sorry, multiplying 4 to the number of units from the vertex to the focus, which is 3. And since your graph is facing left, thus we need to multiply negative 3 to 4. So therefore, we are going to have now y minus 5 squared equals negative 12x minus 6. And for that, the axis of symmetry is parallel to the x-axis. So where is the axis of symmetry? um, the axis of symmetry will divides this one, the dash line. This line divides your curve into two equal halves. And is this really true that this is parallel to the x-axis? Yes, this is parallel to the x-axis. Okay, another example that concerning about finding the equation of parabola. Okay, so the problem there is find the equation of the parabola that has a minimum at negative 2, 6 and passes through the point 2, 8. So if you will be thinking of this minimum, what do you mean by minimum? The minimum refers to the vertex of a parabola. Okay, when we say a parabola is on its minimum point, that means your parabola is concaving up. The minimum refers to the vertex in which having a range with the least value. So when we say maximum, the parabola is concaving down. So when we say concaving down, the vertex is on its maximum point, because at this particular point, the range there has the greatest value among all the range in the curve. So meaning, regarding this problem, your parabola is concaving up. Okay, as you have seen the graph. So as you have seen, the vertex is negative 2, 6. So that's it. And it passes through the point 2, 8. So how do we look for the equation? Okay, so for that, the axis of symmetry is parallel to the y-axis. And then the vertex is negative 2, 6. So therefore, we know it already that the negative 2, the x coordinate is the h, and the k is the y coordinate. So we are now looking for the equation, but since this is concaving up, so we are expecting that uh, the x is being squared. So if the x is being squared, then it is being described by the formula, the standard form, which is x minus h squared is equal to c times y minus k. And then it is being mentioned that our vertex is negative 2 and 6. So we will simply uh, substitute the h by the negative 2 and the 6, while the x and y will be substituted uh, by the point in which your curve is passing through. So therefore, let us have, uh, okay, so the x is 2 and y is 8, and that is coming from this 2, 8. Okay, so the x is being substituted by 2, and then which is minus, and our 8 itself is negative 2. Okay, raised to power of 2, and then we are looking for the c, the constant of the right term or the right part. So where did we get the 8? The 8 is the y coordinate in which the graph is passing through. So it's 8, and then the 6 refers to the k, or the y coordinate of our vertex. So for this to further simplify, 2 times 2 minus negative 2 will gives us uh, 4. This will be 2, and then this will be negative times negative. This will become positive 2. So 2 plus 2 will be 4, and square 4 will be 16. And 8 minus 6 will gives us a 2. And then attach the c, will be getting the c. So therefore, why it is 8? Because the c has a 2. And then we do both divide by 2. So therefore, 16 divided by 2 is equal to 8. And for this, since we are looking for the equation, it should be expressed in this way. There should be an x and y. So this time, we can now substitute c as 8. So therefore, our equation will be x plus 2 squared is equal to, since our c is 8, therefore it's 8 times y minus 6. Is it really correct if our vertex is negative 2, 6? So for this, if we will be getting the vertex out of this, we have the additive inverse of positive 2, which is negative 2, and negative 6, the additive inverse is positive 6. And so we come up with negative 2, 6. So therefore, our equation, which is being found, is correct. Okay. Okay, so far we graph a parabola given a standard form of the equation, and then at the same time we also find the equation by the given. And this time we are given a different equation other than the standard form. So what shall we do? Okay, we are going to see to it what particular variable is being squared. And then so far, the variable which is being squared is y. So we will be expecting what equation or standard form we need to follow. Okay, then so far, we will be gathering all the y term or y variable and then place it on the left side. And then that's it. The y squared, the 4y is being placed on the left, while the x part will be placed on the right. And to what standard form of equation shall we follow? Okay, so far the y is being squared, so we will be using standard form of equation b. Okay, so for this, y we have two blanks, one from the left and one from the right, because as you have seen that this part is said to be a square of a binomial. So when we see square of a binomial, we will be expecting to expand this and to become a perfect square trinomial. And how to expand this? By squaring the first term minus twice the product of the first and the second, and then squaring the last term. Okay, and this is already known to be a perfect square trinomial. So therefore, what will happen if the quadratic term and the linear terms are already given? How do we fill in the third term? Okay, so we have to uh, divide this one, the linear term, always by a 2. And then the quotient there is 2. Then you square the 2, we have a 4. And what shall we do with the 4? The 4 will be filled in on the left side, and we also uh, add a 4 on the right side because we have added a 4 on the left, so both sides should be added by a 4. And then what do you call this trinomial already? And this is what we call a perfect square trinomial. So if it is a perfect square trinomial, how do we give its factors? So the factors are y plus 2 and y plus 2, because getting the square root of the first term is y, getting the square root of the last term is 2, and then whatever the sign there will be followed. And this perfect square trinomial, its factors are square of a binomial, but we can write it instead of y plus 2 times y plus 2, we can write it in that way. And then so far, it will be 10x plus 20 already because 16 and 4 can be combined. And what is the next move? We have to uh, have now this part, y plus 2 square is equal to 10x plus 20. And then we are going to adjust them into this b standard form of equation. And then how do we write 10x plus 20? What is common in 10 and 20? Of course, the common there is 10. So 10x divided by 10, we have already a 1 here. And 20 divided by 10, we have a 2. And then as you have seen, we have already adjusted this into this form already. And for that, we have to see to it what variable is on the right. And since the variable on the right is x, so we will be expecting to have a concavity of either left and right. But since our constant is positive 10, so it will opens right. And then what is its vertex? So the vertex is where is our where is our x part? There is your h. So this is positive 2. So our h coordinate of vertex or x coordinate is negative 2. While our y, we have a y plus 2. So our y coordinate will be negative 2. So that's it. And so far the vertex is negative 2 and negative 2 plotted already. And then the focus, why, how do we get the focus? Is by getting the constant before the linear part. So it's 10 over 4 or 2.5. So what is that 2.5? That means from the vertex, we move 1, 2, and that is 2.5. So that is already the focus. So if that is the focus, okay, it concave right or it opens right. So therefore, the focus is can be found in this particular coordinate 0.5 and y is negative um, negative 2. And then next we have uh, to get the directrix. So the directrix is still 2.5 units from the vertex, but okay, it can be found in here. So 1, 2, and still 2.5. And what is the equation of your directrix? It's x equals negative 4.5 because your directrix is crossing 1, 2, 3, 4.5. And then the latus rectum is 10 units. So overall length is 10 units. So that means 5 units up and 5 units down. So we have this from the focus. Remember that the latus rectum passes through the focus. 1, 2, 3, 4, and 5. And there is the other end point. Going down 1, 2, 3, 4, 5. Okay, and there is the second endpoint, and that will be named as zero point 0.5 and negative 7. Okay, are we now ready sketching the curve? Okay, remember the latus rectum is 10 units, and so far the curve or the parabola is being sketched, described by this curve. Okay, so what is lacking there? The axis of symmetry, it divides the graph into two equal parts, so therefore, that will be described by this dash line. And what is the equation of that axis of symmetry? Okay, y equals negative 2. Okay, y equals negative 2 because as you have seen, 1, 2, so it crosses the y at negative 2. Okay, so I hope guys you've learned something from this conic figure about parabola, and I hope you will never uh, miss some of my videos coming, and then please do not forget to subscribe, like, and share. This has been Teacher Justina, and thank you for watching. Goodbye, and that in all things God may be glorified.